the new exciting family of DVGAs. Okay, so these parts are basically derivatives of our 6402 and 6403 family. It represents the first foray into this DVGA market for us, where we're going to integrate or include in an MCM format the new the DSA core we released about a year and a half ago now with our latest and greatest gain blocks. Later on, we'll start doing the same thing with LNAs, then with driver amplifiers, and maybe with linear PAs, looking down ahead, maybe another 6 months or even 12 months from now. 6411 and 6412 are the two different part numbers. And these are secondary to the DSA family itself, which are 6402 and 6403. Okay, so compared to the DSA family, these parts obviously have gain. We have it with the gain block. They roughly about 20 dB nominally. The other big feature is the frequency response. The parts now cover up to 8 gigahertz. One of the things that we mentioned when we discussed the 6402 is that family and the 6403, the DSA family is capped at around 6 gigahertz. What we found out when we integrated these parts in an MCM, we ended up moving the die for the DSA over to the corner of the package. And in doing so, basically the bond wires were shortened up, and that improved the frequency response for the part. So now, in aggregate, with putting cascade with that amplifier, the part works well up to 8 gigahertz, which is great because now it addresses many of the new applications that we're seeing in that 6.4 up to 7.2 gig and beyond type of frequency range. The 6411, the key difference is the same cores. It comes down to the amount of I/O that we're able to bring out. So with the 6411, we aim for coming out with the smallest possible footprint achievable with the integration again of that DSA and the amplifier. So we use a 3x3 QFN16, and with that package, you only have 16 pins. There's only so much you can do because the DSA has an input and an output, and the amplifier has an input and an output. So that only leaves you with the basic SPI interface to use for programming, as well as the RFA bit. The 6412 with a larger 4x4 package, it's a QFN 24. With those added pins, we bring out the 3 address bits. So with those 3 address bits, you can hang up to 8 devices on one common SPI bus, and more importantly, one common SPI enable. So that would greatly reduce the amount of I/O you have from your micro. A lot of the applications that we sell these parts to, think of like a cellular booster repeater that has multiple paths. You might have up to 8 of these DSAs on the design itself. So with that one common PCB, you can hang 8 of these and just with one simple SPI bus control all of them with one common control. Okay. Yeah, so there are certain customers that would like to invert those 2 blocks in the cascade. The majority of customers that we've come across typically will put the DSA first, followed by the amplifier. And in that case, both parts work equally fine. However, there are certain instances where they want to improve the noise figure of the lineup, or they may want to change the routing ever so slightly. Maybe they want to put a filter in between one of the blocks. In that instance where you want to invert the block order, you can use the 6412. It lends itself a bit, in a bit more effective way with the routing. You can come around in that case, from the eastern flank of the package, come around the southern flank, and then come back in through the DSA core, and then go back out the western side of the package. So it has a little bit more latitude. If I was a customer and size was not as big of an issue, I would definitely go with the 6412. Because again, it added flexibility. In terms of differentiators, the biggest one again is rapid fire. Okay, that's a feature that we introduced with the 6402 and 6403 DSA. We're obviously using that same core in this new family of devices. Rapid fire, what that represents, it's essentially a hybrid control mechanism. That's the best way I've been able to convey this message to customers. And what I mean by that is it gives you the simplicity of a SPI interface, namely basically the 3 SPI control lines with the speed of a parallel interface. So what we do with that, with the rapid fire function is that we allow you during the provisioning state to program up 2 different attenuation registers. One is for the primary state, one is for a secondary state. And then after the provisioning is done during normal operation, you use one external control bit to toggle between that primary and secondary state. And the speed at which you can rotate or switch between the 2 states, it's the same as if you were doing it with a parallel interface. So that can be as low as like 40 nanoseconds if it's state to state or adjacent state to adjacent state. And then of course the speed does vary if you go from full attenuation to minimum or inverse from minimum to maximum attenuation. But the key here is the same speed as if you were controlling those bits with the 7-bit external control or parallel control. The fact that you can invert the order of the blocks is a key differentiator with the 6412. The latitude you have because we bring the I/O out for both cores. A lot of our customers are attracted to that feature. Perhaps they want to place a block in between the DSA or the amplifier or add more amplification.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.